Hello class, this is CSE 4600, Section 1, Week 4, Spring 2025. Okay, now that we have our discussion on P-threads all started and done, I'd like for us to get started with our next lab. So this is lab 2, and it is really 2 programs, but one of them involves a lot of code to write. It is involved, but I will walk you through not only what the code is to be written, but also what it does. So, let's start simple with the Hello World program that's part of this lab number 2. So, first to get started, let's create a brand new source code file, and I'm just gonna do this. Ubuntu has a text editor we can use. I'll make a brand new document and save as, and I'm going to save it in the location lab 2. I'll name it pthread.c. There we go. So now we have our source code file here. Now we can get to work with writing our code. So first, let's get started with the boilerplate code. So this is a simple Hello World program, but it does involve pthreads as well. So we're gonna write a multi-threaded, well, really a 2-thread Hello World program where the one thread returns a message. So let's get started with the boilerplate code. As I said, standard io.h, standard library.h, pthread.h, and just string.h. Okay, let's begin with writing that thread function. So the return type of, so functions can be passed to a pthread, but they must have a specific return type. That return type is void star. So this is a pointer that can be casted to any other pointer type in C. So hello, and if you want to pass in arguments to this function, they also must be a void star, type void star. We're just gonna pass in a thread number. It's of data type void star, but we're gonna cast it back to an integer data type. Well, technically it's a long data type, but here we go. Let's have a simple print f hello from world from thread percent ld exclamation point \n quotation mark, and we're gonna pass in the thread number that was passed in, but we need to cast it back to a long. So I'll just do that. There we go. Then we're gonna send a message back from the hello world function. So this is gonna be a character array. So character star. This is a pointer to our character array called message. We're gonna allocate some memory. So that is character star malloc. We're gonna say 50 times size of characters. There you go. And then we're gonna copy the message as follows: strcpy message, comma, thread has successfully exited. There we go. So this is just gonna copy this string into here, into this message. Then we're gonna send that back. So we're gonna use pthread exit, and we're going to cast that pointer to void star. There we go. So pthread exit is called when a pthread, well, is ready to exit. So we're just going to leave it at that now. And now we can get to work with writing our main function. So when we create a pthread, we need what's called a thread handle. So pthread t thread handle. So the data type for thread handles is pthread t. Then we can create a thread. Well, we can create any number of threads. There are some conventions there are some things we have to do to make it work. Such mainly, I guess it depends on what kind of work you're doing. If you want to run multiple threads as part of a team of threads, you might want to put the function called for pthread create within a for loop. I might show an example of that later on. But for now, let's just get started with one thread, and that is pthread create. We're going to create one pthread. We need to pass in the address of that thread handle. We're going to pass in null. We're going to pass in hello. And hello was the function that we made up here. We're passing a function to a function, basically. And the last thing to pass is we're going to pass in an argument into here. We're going to pass an argument into pthread create that would be passed on to this function here. What are we going to pass in? Let's pass in a thread number. So I'm going to say long thread number equals 1. Well, it really should be 0, but we're only working with one thread, so I guess it doesn't really matter. So let's just say long thread number equals 1. We're going to pass in our thread number, but that's not quite right. We actually need to cast that to void star because, well, we need that to be of that data type because that's the data type that the thread function must accept. So we're casting it from long to void star. Okay? We can then have the main thread say hello world. We can simply say print hello world from the main thread. There we go. And we're gonna call pthread join. When the main thread calls pthread join, it's gonna stop and wait for its child thread to finish. There's only one child thread, so you just have to wait for one. But we're gonna say pthread. No, we're gonna say wait for the child thread to join back. So we're gonna say pthread join. We're gonna pass in our thread handle. And then the second argument would be null if the thread has nothing to return. But we do have a message being returned, and it is this message. So really, before I write that, I need to write this. Character pointer returned message. There we go. Now, we need this to be cast to void star star, and then we have to pass in the address of this pointer. So ampersand return message. So now we have our message. We can print it out. I'll just simply say message reads %s \n, and then there we go. Now we can print our returned message. Okay. One other thing is this. This was allocated memory, so at the end of the program, we need to deallocate our memory so we don't have a memory leak. So deallocate memory. There we go. And finally return 0. And that's our Hello World program. So I'm going to open the terminal at this location. So right click, open in terminal, and now we need to compile this program. It's going to be gcc-o. The name of our executable, usually it's just the name of the source code file without any file extensions at all. So pthread and then pthread.c. That is our source code program. That is our source code file. But we need one more thing, and that is -lpthread. There you go. Now I can run the program using /pthread. And it works. So there's only one thread here. It's just one main thread saying hello world, and then the main thread saying hello world, and then the child thread returns a message back to the main thread. Thread has successfully exited. There is a little bit of a caveat here. We are saying that the thread successfully exited, but here's the thing. Every pthread function in the pthreads library, they all return an error code. So it could be the case that we encounter an error, and no, it would not have successfully exited. That's just something to keep in mind. We can use these return values for further debugging if we need to, but at this point, we are going to forgo any sort of pthread error checking, just for the sake of getting our programs to work. If we are to work with this in any professional capacity, it might be a good idea. It may be a good idea to, do error checking, Okay. So for part 0, all you gotta do here is modify this message modify the message here so it can be anything you want. You might want to change the amount of memory allocated as well if your message is particularly large. Okay? So that's part 0. Take a screenshot of your output and copy your source code, and that's going to be it for part 0. Parts 1, 2, 3, and 4 are far more involved, but they are all part of the same program, and that is, we're going to try out the producer's consumers problem. So let's recap on the producer's consumers problem. It is a problem in the field of operating systems where we try to get threads to synchronize with one another. So the solution that was posited in the slides used what is called a semaphore. So it actually used 3 semaphores. The first one was being used as a mutex lock. So that is a binary semaphore or a mutex. We basically use it like it's a lock. So one thread acquires the lock, and then it locks out all other threads from the critical section. So that thread has exclusive access to the critical section. It's gonna do its thing in the critical section. In this case, it's going to either take an item out of the buffer or add an item to the buffer, depending on whether it was a consumer or a producer. And then, once it's done, it's gonna release the lock, so any other thread that was waiting for the lock can acquire the lock. One thing I need to clarify is the use of the 3 semaphores here. So there are 3 semaphores. One is for counting the number of full slots. So think of the full slots as a resource. Every time think of the empty and full semaphores as counts for the number of resources. So a semaphore is a variable that counts the number of available resources. These are incremented and decremented using 2 special functions called down and up. When we increment down, it might go to sleep if the value of the semaphore was 0. When another thread calls up, and another process, if another thread calls up, and there was already another thread in the middle of calling down and it fell asleep, that thread that called up signals to the other thread to wake up and complete its down operation. So really what's going on is the number of empty slots and the number of full slots. They are their own resources in a way. So if the number of full slots is 0, that means there are no more items left in the buffer. So the consumer, as it takes items out of the buffer, it decrements the number of full slots until it reaches 0. The producer increments the number of full slots using the up operation. The consumer uses the down operation. Conversely, the producer increments the number of... Hold on. Okay, so let me try this again. The number of full slots goes up every time the producer adds to the buffer, and it goes down every time a consumer takes from the buffer. The number of empty slots goes up every time a consumer takes from the buffer, and the number of empty slots goes down every time the producer adds to the buffer. When the number of empty slots reaches 0 and the producer tries to add to the buffer, the producer goes to sleep. If the consumer tries to take from an empty buffer, that means the number of full slots was 0, and then the consumer goes to sleep. So since these are semaphores, when they try to call their respective down operations, they'll go to sleep. It's once another process. If a consumer goes to sleep and a producer adds to the buffer, it wakes up the sleeping consumer. If a producer goes to sleep and a consumer takes from full buffer, the consumer wakes up the producer. So that's what's going on with the 3 different semaphores. With our code, we are not going to be using semaphores, rather we're using condition variables. But the output is still the same. We have the producer's consumer's problem just with condition variables instead of semaphores. Alright? Okay, so let's create... I shouldn't have closed that, but let's do this. I'm going to create a brand new document, and I'm going to save that as pcp.c. PCP short for producer's consumer's problem. PCP can also mean another thing, and the other thing that comes to mind is post's correspondence problem. You might learn about that in CSE-5000, by the way. Okay, let's continue. So, the producer's consumer's problem has us writing quite a bit of code. Let's begin with the boilerplate. So, include standard io.h, include standard library.h, include pthread.h because that's the pthread's library, and we need one more thing, Unix standard.h. So include nistd.h. That has a function that we need for later on. Okay, now we need to define a couple things. We're going to define the size of a buffer. There we go. This is our buffer size. We're going to create a variable and set it to 0. This is the number of items in the buffer, but before that, we should have int buffer and buffer size. This is the buffer itself. There we go. Next, we need our mutex and our 2 condition variables. So pthread, the data type for a mutex is pthread mutex t. This is our lock that one thread at a time will acquire. Oh, whoops, I forgot a semicolon. Pthread cond t, that's the data type for a condition variable. this is condition variable for not full. And p, oops. There you go. pthread const t not empty. I don't know if you can hear that, but there are police sirens outside right now. Okay. Finally, we need to define our produce and consume times. So we're going to say int produce time equals 1. How long it takes to produce an item. So after that, int 2 equals, okay, so int produce time 1 and int produce time 2. So it takes basically it takes 1 second for a producer to produce an item, 2 seconds for a consumer to consume an item. There we go. And oh yeah, we need to define the number of items to produce. So int items equals 10. So it's a bit involved, but yeah, don't worry. I'll walk you through what to do. Okay, so our next step is to write our producer function. So void star producer. Now we don't have anything to enter or return from, so I'll just populate this with, I'll just add return null at the very end. There we go. Now we're going to begin with a for loop. So for int I equals 0, I is less than num items I plus plus. So it's going to be producing items in a for loop. So the code to be executed in the for loop is, we're going to produce an item. Let's simply say the item is this. I plus 1. So it's going to be adding numbers to the buffer. Alright? So it's made an item. Before it adds an item to the buffer, it needs to acquire the lock. So pthread mutex lock, and we're going to pass in the address of our mutex. The mutex is a shared variable, so that way every thread will have access to the mutex. There we go. So acquire the lock, check if the buffer was full. If it is, wait for it to empty. So while count equals buffer size. So count is the number of items currently in the buffer. Buffer size was the size of the buffer that we've defined. If the count equals buffer size, that means the buffer is full. If that's the case, wait for the buffer to empty. Print f buffer is full. Producer is waiting for buffer to empty. There we go. And now we say pthread const wait ampersand not full mutex. There we go. Now we do have to pass in the mutex in as part of our pthread condition wait function call. So we pass in our not full condition variable plus the mutex. Technically, it's the addresses of the two. So when this function is called, the calling function will wait until another thread calls the corresponding signal function call. So if the buffer is full, it's going to wait. It's going to call pthread condition wait, pass in not full, and if the consumer calls pthread condition signal and pass in not full, it's going to basically awaken the producer. So it will continue to the next step, and that next step is add an item to the buffer. We can simply say buffer count plus plus. So this is a shorthand for several steps. It is add an item to the next available slot in the buffer, and then increment the count by 1. There we go. So really, this is shorthand for 2 lines of code, and those 2 lines of code are as follows. So the increment the so it's basically add an item to the buffer and then increment the count so we can add an item to the next available slot. So that's just shorthand for those 2 lines of code are the same as this single line of code. You can write it either way, doesn't really matter. It will still work either way. So then we can say printf producer has added an item to the buffer. %d. We're gonna say what item we added, so that item. So here's the other thing. If the consumer tried to take from an empty buffer, the producer will then signal to the consumer there's an item to be taken out. So if the buffer was empty, signal to the consumer. So pthread const signal not empty. Okay, so now we're done with adding an item to the buffer. We can release the lock. So that is pthread mutex unlock. Pass in the address of the mutex. There we go. And finally, we're gonna sleep to produce simulation time. No, so to simulate production time. So sleep, where our produce time was defined up here to be 1 second. There we go. So that is our producer thread right there. Maybe I should just maximize it so it's easier to see the whole thing. Okay, so that's one thread function done. Let's work on the next one. So the next one is the consumer thread. So void star consumer. I'll add a return null at the very end. There we go. So the consumer thread is more or less the same steps, but it's about as involved as the producer thread, except we are taking items out of a buffer. So that means we can start right away with acquiring the lock. Oh, by the way, this must all be in a for loop. So for int I equals 0, I is less than num items I plus plus. So, acquire the lock, pthread mutex lock, and we pass in the address of that mutex lock. So that is pthread mutex lock. Okay, so now it's acquired the lock, it can enter the critical section. First, it's gonna check whether the buffer was empty. If the buffer is empty, wait for it to fill up. While count equals 0, print F, we'll just simply say buffer is empty. There we go. Buffer is empty, consumer is waiting for the buffer to fill. And then we say pthread cond wait dot empty mutex. There we go. So the buffer is empty, wait for it to fill up. Okay, so it's gonna wait. If the buffer is empty, it's gonna wait for it to fill up. Once it fills up, the buffer will now have an item for the consumer to take out. We can take an item out. We're simply gonna say int item equals buffer, and then in square brackets minus minus count. So what this does is it takes a item from the buffer and then decrements the count, so it goes to the next available slot for items to be taken out. Okay? So really, this is shorthand for two operations. That is decrement the count and then take an item from the buffer. So really, we can expand this into two lines, and it's as follows: minus minus count. So decrement the count and then take an item from the buffer. So we could write it as this, or we can write it as this. Once again, same output either way. So after that, once we take an item from the buffer, we can simply say print F, consumer has taken an item from the buffer. Percent D. There we go. After that, if the buffer was full, so I need to put this still in the curly brackets here. If the buffer was full, signal to the producer that there's space for new items. So we're gonna say pthread con signal not full. There we go. Finally, we're gonna release the lock because we've exited our critical section. Oh, we need to pass in the address of the mutex. There we go. And we're gonna sleep to simulate consumption time. Say sleep and sleep. Consume time. Okay, so for completeness, I'm going to add a few more lines of code here. That is producer has finished producing, and consumer has finished consuming. There we go. So now we have our producer thread and consumer thread functions completed. Now it's time for the main function. So the main function is the one that calls the two. It starts up the threads and then waits for the two threads to finish. So let's start writing that out. Hit main, and at the end I'll just say return 0. So first we need to create two thread handles. So pthread t, that's the data type for our thread handle. We need one for the producer and one for the consumer. There we go. Next we need to initialize our mutex and our two condition variables. So pthread mutex init, pass in the address of the mutex, and pass in null as a second variable. Pthread cond init, we pass in one of our condition variables, and null. And finally, I'll just copy this line of code and paste it here. This one's gonna be for the not empty condition variable. Okay, so that is our condition variables made. Let's start up our producer and consumer thread. So here's the other thing I should point out. The producers consumers problem will work with any number of producers and consumers. We're just gonna go with the simple case of one of each producer and consumer. We can make this so that it runs with multiple producers and consumers, but we would need to write a for loop for that, and we would need to make sure that the number of items produced matches the number of items consumed. Okay? Alright. So create producer and consumer threads. So I'm gonna say pthread create. So this creates a new pthread. We're gonna pass in the address of one of our thread handles. So this one's gonna be our producer thread. Then we need to pass in null. We're gonna pass in null for the second argument. The third argument is going to be our producer function, all the way up here. And finally, we're gonna pass in null for the fourth argument because we're not passing anything to our producer thread. There we go. Similarly, for the consumer thread, we're gonna pass in the thread handle for the consumer thread, and then we're gonna pass in the consumer function as the third argument. Alright, there we go. So now we have the producer and consumer threads made. We're gonna have the main thread wait for them to finish. So pthread join, and we just pass in the address of the producer thread. Since there's nothing being returned, we don't need to pass in anything for the second argument, so it's just gonna be null. So producer thread handle null. There we go. And I'm gonna do the same thing for the consumer thread. Pthread join consumer thread null. And now for our cleanup step. Since we're now done with our mutex and condition variables, we need to destroy them. So pthread mutex destroy. We're gonna pass in the address of our mutex. There we go. Pthread cond destroy will destroy our condition variable. So one for not full, and one for not empty. There we go. That should be everything. Nice. Alright, so let's try it out. We need to compile this program using the same command as before. gcc-o. Since our file is called PCP, we're going to call the executable PCP, and we're going to read the source code file pcp.c. And then we need to add a -lb thread at the end. Press enter. Oh, looks like I'm missing a few things. Hold on. Let's make sure. Okay, there are a few things missing with our code. Let's see. Line 7. I forgot a semicolon. That might be the only problem. So, let's try that again. Clear. Hold on. That should be GCC. I typed in the CC, so GCC. Let's try that again. Clear. And /PCP to run our program. Yep. 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 And the producer has finished producing. Meanwhile, the consumer has to catch up with the consuming. And that's because it takes 1 second for the producer to produce an item and 2 seconds for the consumer to consume an item. But after that, the program runs to completion and it works. Nice. Okay, so we're gonna, for part 5, that's the part where you get to experiment with the code. I have you experiment with the code in 2 ways. First, we make the number of items to produce larger so that we want to get the producer to go to sleep. We want the buffer to fill up so that the producer goes to sleep. So we want to increase the number of items being made from 10 to, say, let's do 40. Now this might take some time for the producer to go to sleep. But we're going to compile it and run it again. Oh, there it is. The buffer's completely filled up. I think it slowed down because there were probably other background jobs running that needed to turn on. Maybe something about this is bogging down the CPU, so that's why there was a moment where the consumer was just taking items from the buffer, and I guess the consumer was just bogged down. But yeah, there were moments in time during this execution where the buffer filled up, and the consumer had to wait to add items to the buffer. So yeah. Okay, at this point, the producer has finished producing, so now it's up to the consumer to empty out the buffer of all final items. And there we go. The program has finished. So, yeah, it works. Nice. So, basically describe what's going on. Yeah, briefly describe what's going on with the producer and consumer. So, at some point, the buffer fills up, and the producer is producing faster than the consumer can consume. So basically, at some point, the producer fills up the buffer and goes to sleep. The consumer can't consume fast enough, so every time the producer adds an item, it can't add any more because the consumer, needs to first take out an item. So it's going to sleep like nearly every time so it's going to sleep quite often because, the producer is going to sleep quite often because the consumer has yet to take out another item. And that's because the producer is producing faster than the consumer can consume. So that's what's going on here. So briefly describe in your own words what is going on here. And that is change number 1. Change number 2 is getting the consumer to go to sleep. So for this to happen, if the producer goes to sleep because the consumer takes more time to consume an item, if the producer produces items faster than the consumer can consume, then the consumer will go to sleep. So let's try that out. So we can do this simply by swapping the produce and consume times. And that's exactly what I had you do in the lab. So we're going to recompile our program and do it again. So here I want you to describe the behavior of what's going on here, but I think you probably got a good idea of what's going on. The consumer is consuming faster than the producer can produce. Therefore, every time it tries to take from the buffer, it must wait until the producer has added to the buffer. So the consumer is going to sleep every time it wants to take from every time it tries to take from the buffer. So that's what you need to describe here. So basically, when it comes to this, you need to take a screenshot of the producer going to sleep, take a screenshot of the consumer going to sleep, briefly describe what's going on with the producer going to sleep, and quickly describe what's going on with the consumer going to sleep. Okay? So those are your lab instructions, and these will be posted on Canvas as well. And that's basically it for this lab. So let's look at the points values. So 2 things for part 0, and they're both 5 points each. Source code, which caused the message returned, and a screenshot of the program running for part 0. That was a simple Hello World program. Parts 1, 2, 3, 4, and 5, they are all part of the same program. So I'm just gonna have you submit your source code. Since it's a larger program, it's gonna be valued at 10 points, and then for the producer going to sleep and the consumer going to sleep, that's 10 points each. 1 for the screenshot of the producer going to sleep, and 1 for a screenshot of the consumer going to sleep. And a description of what's going on, and what value did he set to get the buffer to fill up. Okay? So this, all in all, is 5, 10, 20, 30, 40 points total. It is a fairly large program you have to write, but that's why I have it broken up into steps. Okay? So that's the producer's consumer's problem. Okay? Alright, that's going to be it for this lab, and follow along, and if you have any questions, let me know either in office hours or in class. Okay? Okay, alright. Thank you. Bye.